for question, so this is the fourth question of 2016, right? It says, consider the differential equation. They're usually pretty good about saying differential equation, right? But so consider the differential equation. So here's your formula. On the axis provided, sketch the slope field, right? And they're not nearly as tedious as some of the problems I've given you, which is thankful because that take forever. And pretty much your job are each of these dots, you got to figure out what the slope is. So for part A, we start. I want to find out what's happening at 0, 0, what's happening at 0, 1, and what's happening at 0, 2, what's happening at 2, 0, what's happening at 2, 1, and what's happening at 2, 2. So at 0, 0, that's easy. We get a slope of 0. At 0, 1, let's see, if I plug in 0 for x and 1 for y, I'm going to end up with a negative 1. At 0, 2, I end up with, let's see, 4, end up with a negative 4. For the next one, if I plug in 2, 0, if I plug in a 2, that's going to give me a 1 and a 0 on top, which is going to give me a 0. If I plug in 2, 1, I get a 1 on top and a 1 on the bottom. If I plug in 2, 2, I get a 1 on top and a 4 on the bottom, so I get a 4. So again, doesn't take too long. Now it's time to draw your picture. And at 0, 0, you really want to make sure that your slopes of 0 are obvious. You also make sure your slopes of 1 or negative 1 are obvious. So at 2, 1, we have a slope of 1, so we have a 45-degree angle. At 0, 1, we have a slope of negative 1, so we make sure that's our 45-degree angle. And then this is a negative 4. Yeah, I'm not great at drawing it, and you don't have to be. You just have to make sure that's a steeper slope than this one. And the same thing over here. So part A, not too bad. Unfortunately, it's usually only worth a point. Now for the other stuff. Now we're out of room, so I need to get some paper. Part B, and this is an very, very typical thing. You're actually going to see this. I think it's in the next two questions as well. So for part B, it says, let y equal the particular solution to the differential given equation with an initial condition this. Write an equation for a tangent line, and then use your equation to approximate f of 2.1. All right, huge. Anytime it says write an equation of a tangent line, the first thing you pops in your head is to find an equation of a tangent line. I need a slope, and I need a point. And whatever you say, if equation of a tangent line, I need a slope and a point. The only point they've given us is this. So I have the point. I'm going to have the point 2, 3. How do you find your slope? Well, that's where our differential equation comes in. So when I plug all this in, I'm going to plug 2 in for x and 3 in for y. So that's going to give me a 9 over 1. So my slope is 9. And pretty much what I want you to do at this point, you write down y minus 3 is equal to 9 times x minus 2. And we've just done the first part. It says write an equation of the tangent line. And it says use your equation to approximate 2.1. So then they're telling you plug in 2.1. So if I plug in 2.1, that's going to be 9 times 2.1 minus 2 equals y minus 3. End up with y minus 3 is equal to, well, it's going to be 9 times 0.1. So end up with, y equals 3.9. Done. So I really want to stress this particular question. This is an easy question. I don't care how ugly the problem is. When they say find an equation of a tangent line, you have to know, I need to know the slope and a point. Once you know the slope and the point, you can plug that in so that you can figure out, find an equation of a line. And you will be asked to approximate, you will be asked to approximate values. That's when they always ask that type of question in the differential equation part. So usually this is worth, like drawing the slope field is worth a point. This is probably worth 2, maybe 3, right? There's 9 total points. This is the one where you get your points. And I really want to talk about this. This is what we were practicing Monday and Tuesday. And in a perfect world, we would practice this a whole lot. It's not a perfect world this year. You're still going to be asked this. So find the particular solution. And it says find a particular solution. That's code for you are solving this differential equation. So dy dx equals y squared over x minus 1. And when they say particular solution, they've got to give you a value, and so they're also telling us that f of 2 is equal to 3. So now you start. And actually, I'm going to pause this. So, solving a differential equation. Separate the variables. Y is on the left, x is on the right. So, step 1, I got to get all the y's on this side. I'll end up dividing both sides by y squared, so I end up with dy over y squared. Multiply both sides by dx, I end up with dx over x minus 1. So when you separate the variables, that's step 1. Step 2, we're going to take the integral. Now, when we take the integral, right, this side probably would help to think about as y to the negative 2, so that's going to give me y to the negative 1 over negative 1. And the integral of this side is going to give me natural log of x minus 1. And you have to remember the plus c. And I'm going to talk about, when we actually look at the rubric, I'm going to talk about, we're going to see the importance of the plus c. All right, so now there's some algebra involved, so I end up with a negative 1 over y is equal to natural log of x minus 1 plus some constant. I don't like the negative sign, so I'm going to multiply everything by negative, so I'll end up with 1 over y equals negative natural log of x minus 1. The great thing, a negative number you don't know is still just a number you don't know. All right, so now what do you do? Right? You want y by itself, right? That's our goal. Well, there's actually 2 things, and I haven't, when I did the lesson on Monday, I didn't talk about advanced tricks. The way that always works, get y by itself, and the way you can get y by itself here isn't too bad. If you got 1 over y equals this, if you got 1 over y equals stuff, you can just flip both things. So that's going to give me y is equal to 1 over negative natural log of x minus 1 plus c. Just make sure that plus c stays in the bottom. And you've got your information where it says you plug a 2 in, you better get a 3. So you can do that. There's absolutely nothing wrong with it. This says when you plug 2 in for x, you get a 3 for y. So that's going to give me 3 is equal to negative 1 over, actually, yeah, I'll have 1 over negative natural log of, plug a 2 in, so 2 minus 1 is 1, plus c. Well, natural log of 1 is 0. So end up with 3 is equal to 1 over c. So turns out that c is equal to, this tells me that c is equal to 1/3. And so I can plug all this in and I end up with y equals 1 over negative natural log of x minus 1 plus 1/3. And you can leave your answer like that. We'll see that in a little bit. So that method always works. Advanced method, for people who are a little more comfortable, at any point you can figure out what c is. Sometimes trying to figure out c at the end, sometimes trying to figure out c right after you, at this stage, is a little easier. For example, if I plug in, once I have a c, I can plug in this, all right, pages, I'm missing the board. I can plug this in for x and plug this in for y. And at this stage, let me write it up here, f of 2 is equal to 3. So if I plug a 3 in, actually I'll just plug it in here. If I plug the 3 in for y, I get a negative 1/3 is equal to natural log of 1 plus c. I just found out that c is equal to negative 1/3. And, you know, so if once I found out that, well, I guess one of the tricks is if you found out c equals negative 1/3, then you have to start here. So I get negative 1 over y is equal to natural log of x minus 1 minus 1/3. Now when you solve for y, you got to change the sign. So we end up with 1 over y equals natural log of x minus 1 plus 1/3. And so y is equal to 1 over this mess. Natural log of x minus 1, negative 1 plus 1/3. And when we look at the rubric, we're not going to see that part. Right? What you're going to notice, particularly in the next couple of examples, is sometimes finding c earlier is easier than finding c later. Now, that's a big mess. I want to look at the slopes. I want to look at the rubric, because I want you to see how things are graded. Part A. Oh, you got 2 points for doing the slope field. Notice they said you get 1 point for making sure your zero slopes are fine, and you get 1 point for the others. You know, there's your negative 1, there's your positive 1. They're not being super accurate here. They just need to know that that's steeper. For part B, they ask you to find an equation of a tangent line. They have this version. I had y minus 3 equals this, but you found your equation, so we end up with 2 points. You get 1 point for making sure you get the tangent line, which is here, and the other, well, we got 3.9, same thing. This is where most of your points comes from, and it's kind of funny what they give you credit for. So 5 points, here's what you get. Separate the variables. You get 1 point if you can just remember to put the y's on the left, the x's on the right. You get 2 points for the antiderivatives. Did you take this integral right? Did you take this integral right? Right. So if you can separate variables and take an integral, you can get 3 of the 5 points. Now to get the rest of it, you got to remember to put a plus c and if in their solution they actually figure out what c is at the beginning of the problem. Oh, and then I thought they would have cleaned up that 1/3, but they didn't. So we end up here. So when you are solving a differential equation, right, you get points if you can separate and take an integral. And then you don't get other points. They're actually a little more generous here. Normally, if you don't do, it says note max 3 out of 5. Usually it's max 2 out of 5 if no constant of integration. Of course, you don't get any points if you didn't separate the variables. All right, so that was an AP question. Can you draw a slope field? Can you do the, can you answer usually an equation of a tangent line? And then can you solve a differential equation? That's a pretty common theme. So in 2017, they asked this question. And I'm going to read the whole thing, and this became known as the potato problem. I can remember my students in 2017 when they took this, they came back and said, what the heck are they doing with the potato problem? So let's talk about this type of problem, because this is a differential equation question, and they actually identify that. And they put a lot of words with it. And I want to make sure you can decipher the words and not freak out with it. So, let me start off. At time t equals 0, a boiled potato is taken from a pot on the stove and left to cool in the kitchen. Blah, blah, blah. The internal temperature of the potato is 91 degrees at time 0. The internal temperature of the potato is greater than 27 degrees for all times greater than 0. Right. Okay. The internal temperature at time t minutes is modeled by a function h that satisfies the differential equation where h is measured in degrees Celsius. All right. That's a lot of words, right? And I honestly think that just freaked out all of my students that took this in 2017. Here's what you need to get. This is some things you need to pay attention to. It says differential equation, and they give you this, right? Once you see differential equation, if you don't like h and t, you can change them to y's and x's. But, it's a differential equation where they change the letters. I think that if they'd had y's and x's, I think it would have been fine. But the h's and t's really messed a lot of people up. And the statistics for this particular question, keep in mind there's a max of 9 points. The average for this year, I think, was less than 2. Right? Like, average across the nation was less than 2 points for this. Which, that was the part that really was hard to swallow was, yes, I get that this was a harder question, but when we talk about question 1, we'll see that. All right, so first thing I noticed is a differential equation. The next thing I noticed, it says the internal temperature of the potato is 91 degrees at t equals 0. They're giving you a point. They're telling at time 0 we get 91. All right. Oh, and I didn't tell you that here. Just in case you missed it, they're saying your coordinate is at time 0, you get 91. All right, part A. Write an equation of a tangent line. Right? Notice they had a question like that on the last problem. This just shows up. Find an equation of a tangent line. To find an equation of a tangent line, you need a slope and a point. They gave you a point. They gave us a point. They gave us the point 091. And they give us a formula for slope. So dh dt evaluated at the point 0, 91. This is your t, this is your h. So we're going to plug this in. So I'll get negative 1/4 times 91 minus 27. So, let's see. Well, not super convenient, right? 91 minus 27. Is that 84? No. No, 64. A negative 1/4 times 64, which gives me a negative 16. There's our slope. There's your point. There's your slope. So for part A, I'm going to end up with y minus 91 is equal to negative 16 times x minus 0. Right? Not an unreasonable question. Say find an equation of a tangent line. The next thing they say, use this equation to approximate the internal temperature at T equals 3. So that means y minus 91 is equal to negative 16 times 3 minus 0, so minus 91. Whoops, you can't read that. Need more space. Negative 16 times 3 is negative 48. And so y is equal to what's that, 50? Sorry, my brain is y equals 43. Right. So the frustrating part was part A was actually worth 2 points. So the fact that the average was below 2 meant that most people that took the freaked out and didn't get at least the 2 points that were find the equation of the tangent line. That was part A. All right. Now, part B. This is where they start asking some tricky stuff, and I need to make sure you're prepared for it. Part B says use the second derivative to determine whether you had an overestimate or underestimate. They typically ask this. So, so you're asked to find the second derivative. So if I start off and I have dh dt is equal to negative 1/4 h minus 27. All right. When you take the second derivative, this is implicit differentiation. So if this is implicit differentiation, when I do d2h over dt squared, you have to remember that whenever you take the derivative of h, that's special. I have a dh dt left over. That 1/4 is decoration, so I'll have negative 1/4. And then the derivative of this is going to give me dh dt. Now, I know it's very, very hard to pay attention through a screen, but if you have it, if you want to get the full points of this, is a very common mistake. Students forget that when they take the derivative, when they find the second derivative, they're doing differential equations. And you've got to remember that when you take derivative of h, there's a dh dt, and you can't just leave your answer with the dh dt, because dh dt is equal to this thing. And so it turns out this is equal to negative 1/4, and then you have to put in what dh dt equals, which is a negative 1/4 times h minus 27, which is going to give me positive 1/16 times h minus 27. So you get points, right? You'll be asked to find the second derivative. Sometimes they give you the second derivative. Most of the time you have to find it. Now here's the interesting part. So if your second derivative is equal to this, and in the question they do something weird. They say something like it's always greater than 27. The reason they say it's always greater than 27 is if h is always greater than 27, this is always positive. In particular, at at h equals, yeah, actually I just say this is always positive. And if your second derivative is positive, that's telling you that it's a happy face. And if you've got a happy face and a tangent line, that tangent line is always going to be below it. And since that tangent line is below it, right, then that 43 is an underestimate. So just sort of go through, I'm going to kind of step through all of this. When you find an equation of a tangent line, this is, that tangent line approximates the function. So this is an approximation. It's either too big or too small. How do you answer if it's too big or too small? You have to look at the second derivative. If it's concave up, think about where you draw your line's always going to be below the graph. If it's below the graph, then it's an underestimate. If it's concave down, then it's going to be an overestimate. So when you look at this, our second derivative is always positive. If it's always positive, that means it's an underestimate. So there's part B. As far as part C goes, then they ask you to go about, they said an alternate model is this thing. So they give you this differential equation. So I'm going to have to write it down so I have room. So they tell me dg dt is equal to a negative g minus 27 to the 2/3. And they also tell us our initial condition. They tell us g of 0 is equal to 91. And they said find an expression. Basically, you have to solve your differential equation. So again, we're going to separate my variables. I'm going to put the g's on the left, the t's on the right. So that's going to give me dg over g minus 27 to the 2/3 is equal to a negative dt. I don't want to put the negative over here if I don't have to. So when I take the integral of this side, I'm going to get a t plus c. If I take the integral of this side, I'm just going to get g minus 27 to the 1/3, because that's g minus 27 to the negative 2/3 when I add 1, times 3. Yeah, take the derivative of this, I'm going to get that part is equal to t plus c. This is one of those cases where I think it'll be easier to plug in this for x and this for g. Yeah, I think it's easier to figure out what c is at this stage than it is later. That's going to give me 3. So 91 minus 27 to the 1/3 is equal to a negative, 0 plus c. Oh, that's going to give us 3. That's 64 to the 1/3. Oh, well, that's 4 times 3, so c is equal to 12. So now when I go over here, I have negative 3 times g minus 27 to the 1/3 is equal to a negative t plus 12. Now I can actually go about solving, because they want me to solve for this. Find an expression for g, yay. So I'll divide everything by negative 3. G minus 27 to the 1/3.
Where did the negative
come from? Where did this negative come from?
No, the negative in front of the 3. Just in the last.
Oh, thank you. Thanks for paying attention. Good job. Should not have been there. I think I was looking somewhere else. So end up with negative t plus 12 all over 3. I'm going to cube that ugly thing. So end up with g minus 27 is equal to that ugly thing, which is negative t plus 12 all over 3 cubed. And yay, g is equal to the massively ugly negative t plus 12 all over 3 cubed plus 27. And then I said, then you plug in 3. And when I plug in 3, let's see, and g of 3, so that is going to be 9 over 3, which is 3 cubed plus 27, which gets 54. Now, this was ugly. And I think College Board recognized this was ugly when we look at their rubric. No. Oh, they were nice on Part B. All right, so let's see how they awarded points. For Part A, you got 1 point for the slope, you got 1 point for the tangent line, and you got 1 point for the approximation. So Part A, even though a lot of this problem I think is actually really hard, you got 2 points for just writing an equation of a tangent line. And so the fact that the average was below 2 means most people didn't know how to find an equation of a tangent line. So that part was a little discouraging. Part B, I think they realized this was really tricky, and since they realized it was tricky, they only let it count for 1 point. A lot of people forgot that they had to plug that back in. So I think they went through and they awarded points. They decided, okay, that's only going to be worth 1 point. Which means you got 5 points for this. And even if you're not comfortable doing a differential equation, everybody in here can separate the variables. You can put the g's on the left, the t's on the right. You get 1 point for the antiderivatives. You should be able to take the antiderivative. If you remember to put the plus c and figure out the c, that gives you 1 more. One of the big deals, notice that you only get 1 point for actually answering the question. So I spent a fair amount of time, like a lot of my computation was sort of these last 2 steps. Typically that's not worth a whole lot, so if you get stuck, most of your points comes from separating the variables and taking the integral. So pretty much if you just separate, take the integral, remember to put the plus c, and even if you just stop there, you get a fair amount of points. Even if your arithmetic skills kind of mess up at the end or you're stressed out. All right. Last problem. And I know I'm not going to finish this whole thing. I am going to talk. I'm probably just going to talk about it. Right? So in problem 2018, again, I never thought they would have you draw a solution curve, but they've done it twice. I think 2018, I think 13 was the other time. 12 or 13 was when they asked it last time. It says, consider the differential equation, blah. They give you a slope field, and they give you 2 dots. They want you to draw a solution curve. So they're just looking for, can you follow the slopes? Look at this. And, they can't be, when we actually look at the solution, they're pretty generous. You don't have to be perfect as far as drawing goes. But again, I want to talk about B because there was a similar question in the last problem. It says, let f be the particular solution. They give us an initial condition. Write an equation for a tangent line, right? And then use your equation to approximate f of 0.07. The same question, right? Give me an equation of a tangent line. What's your slope? Here's your formula for slope. There's your point. Find an equation of a tangent line, then find the approximation. I don't know if you noticed, but the previous two problems had similar questions. It's the same thing. This is what they ask. The last is find the particular solution to the differential equation, and they give you this dot. So they're asking you to solve this. Yeah, I don't have enough time to do the whole problem, but I do want to show you like the solution. Notice part A. You got 2 points if you knew how to interpret a slope field. It says curves must go through the indicated points and follow the slope line and extend it back. I mean, you just got to get close. If you look at part B, this is worth 2 points, right? Can you figure out the equation of the tangent line and figure out the approximation? So even if you had, I mean, everybody should be able to draw the lines. Find an equation of a tangent line. That's something that we've stressed a fair amount this year. And then you get to the differential equations, right? Separate the variables. You get 1 point if you know to put the y's on the left, the x's on the right. You get 2 points for the integrals. You get integral of the left, integral of the right. And so at this point, you've got, of the 5 points, you've got 3 of the 5. Remember to put the plus c, remember to put the plus c and figure out what c is. And my suggestion is if you're worried about time, stop. You got 4 out of the 5 points if you can figure out what the c is. Right? This last bit solves for y. If you're having trouble with it and it's going to cause you stress, it's worth a point. Right? That's not going to make a huge difference. But these first, separating the variables, taking the antiderivative, and finding the constant integration, doing that, that's a big deal. If you have trouble solving for y, if you're worried about it, just don't do it. It's not going to hurt you that much. All right. So here